Batteries. For your torches, for your cars, and for your drones. But how do they work? Let's take a look. And just a quick disclaimer, when I told my mum I was making this video, her advice was make sure you tell them you can't lick a 9-volt battery. You can lick any other kind of battery apparently, but just not 9 volts. So batteries work when you put 2 electrodes in an electrolyte. So a good electrolyte has to be ionic. And to be a better electrolyte, it needs to dissociate well in water. And so for this reason, it has to be a polar molecule. And for that reason, things like lemons, oranges and potatoes can be used to generate electricity, because citric acid can dissociate into H+ ions. In most alkaline batteries that you'd find in your drawer at home, they use the electrolyte potassium hydroxide. And this is a really good electrolyte for household items like TV remotes, etc. because it dissociates well, but not too well. It also uses magnesium dioxide and zinc cathodes, which are relatively inexpensive. So when you need a higher potential difference, you look at something called a lithium battery. These work off of lithium hexafluoride phosphorus, and it works really well as an electrolyte, as the lithium ion and the other ion are easily separated. And the hexafluorophosphorus ion is really stable. And that's how batteries work, no takes backsies. Until 2016 at Bristol University, when they made something called the diamond battery. Now these are really complicated, but basically they use carbon-14, which isn't very radioactive, has a half-life of about 5,780 years. And so they take a core of carbon-14 and they surround it in a thin layer of diamond. Carbon-14 undergoes beta radioactive decay, but it is absorbed by the diamond, and as it is a semiconductor, beta particles can knock electrons out and create electron hole pairs, and this moves around so that it creates 2 poles on a battery. And the strong covalent bonds in diamond prevent any gap being closed immediately. Now, as a semiconductor, diamond has a conduction band and a valence band, and the gap between them is quite large, about 5.5 electron volts. This means the surrounding diamond is really energy absorbent, and that means the battery doesn't get hot easily, and nor does the radiation harm anyone who uses the battery. But then why isn't it used everywhere? Well, it's a relatively new technology, and these things always have to be checked, double-checked, triple-checked, and lots of places still have strict laws regarding things containing radiation. Not to mention issues with costs. Don't forget, lab-grown diamonds are still very expensive to produce. And as long-term as these batteries are, they only produce very small currents. This makes them ideal for things that require long-term power, but very little current. Things like pacemakers or deep-sea sensoring equipment. And finally, before we finished, I just wanted to say I went to Queen Mary University Open Day yesterday, and I loved it, so shout out to all the chemistry staff in the Priestley building. If you're a year 12 or year 13 studying chemistry and you want a good choice, Queen Mary I can highly recommend. So that's it for today's video, guys. Thank you so much for watching. Please remember to like and subscribe, and I'll see you next week for a video on NMR. Bye!